Hello, everyone, and thank you so much for joining for a NeuVector 101. My name is Tracy Walker. I am a solution engineer for NeuVector, and here to talk to you a little bit about NeuVector. I'm going to go with kind of the basics and explain what NeuVector is and how it works. And so hope you enjoy this. So the first thing I want to talk to you about is the difference between vulnerability scanning and runtime protection. Now, this might seem obvious, but not always. Vulnerability scanning is threat-based, right? So you have to know your CVEs. You have to usually have a remediation for that. You have to have a patch or an update or something. It will not help you. You have to know the threats, right? So if you don't know what the threats are, if it's a 0-day or if it's an inside activity happening in your environment, it's not going to help you for that. Inconsistent results vary. Yes, the Department of Defense for US uses 3 different scanners. So not a bad idea to use multiple scanners, especially if you have access to some free open source scanners. Yes, you should use multiple scanners for that. Yes, it's going to require you do some remediation or some tools around that. It's not going to give you access or visibility into the processes, network behavior that's taking place. All you're doing is patching the holes in the wall, right? And if you're using a source code analyzer actually have a problem connecting sources and sinks, right? Sources are the exploit. That's how you can get into an environment. Sinks are all the things you can do once you get in. Source code analyzers don't connect those dots. They don't necessarily know if you can get in this way, this is what you can do with that action. Behavior-based security starts with, well, first you have to know yourself. So that is the big difference. Threat-based, you have to know the threat. You have to know the enemy. You have to know who's trying to get in. Risk-based means you have to know yourself. You have to know your applications. You have to know where the valuable goods are, the data that somebody might find useful or that you're trying to protect if you're in PCI, et cetera. That means if you know your behavior, you can segment from that behavior and identify anything that isn't your behavior. That doesn't mean it's bad behavior if it's not yours, but it is something worth investigating or knowing what that is, what that network connection is, what's running these processes that we haven't seen in other environments. Why are these happening here in production? So that is kind of the difference, right? Risk-based means you can block 0 days, unpatched CVEs, unknown CVEs. And with you're using NeuVector for your behavior-based zero trust runtime. I know that's a lot of buzzwords, but that is what it is. It's behavior-based because we know your application. It's zero trust because we're going to segment between the known behavior and the unknown behavior. That's what zero trust is, no matter how you apply it in various security layers. And that's how you're able to detect if something isn't yours. And that means, yes, we can block anomalous behavior and any source sink correlation because we're blocking both the sources and the sinks. We don't even have to know what they are because they are not our behavior, right? That's how that works. So as I talk about NeuVector, I'm going to break it into scanning and runtime security because this is the easy way to think about this. So we'll talk about scanning first very, very quickly. We can scan at any time in the development lifecycle as soon as the image is built. So we scan images. Once they're built, you can scan those before you push them to a registry. We can scan as part of a CI/CD pipeline. We have plugins for Jenkins, Circle CI, various tools for CI/CD pipelines. We can pass-fail those builds early in the development lifecycle, so you can remediate any vulnerabilities that way. We can scan private registries. We do plug into Kubernetes admission control. Quick point, admission control policies, pod security policies that are being deprecated in Kubernetes. We do not change those. We're not a skin on Kubernetes, and we don't use Kubernetes as our source of truth. I'll talk more about that in the runtime. But for admission control, we have our own admission control rules, and we have added to those rules so that you can take advantage of the scanning and use that as part of the admission control rules. And we do scanning for CIS benchmarks, PCI, HIPAA, NIST, GDPR. We can do reporting on those regulatory requirements that focus around those CIS benchmarks. Let's take a look at what we scan. Starting out with the platform, we scan Kubernetes. OpenShift, Rancher, any flavor of Kubernetes, doesn't matter. We are Kubernetes native. Also, if you're not running Kubernetes and you're just running a Docker environment, Docker Swarm, we can also scan those environments as well. Worker nodes underneath your Kubernetes environment. So yes, these worker nodes, we are scanning for compliance for Kubernetes and finding any vulnerabilities on these Linux VMs. So yes, we can scan the worker nodes underneath the platform. So the platform, the nodes, the containers that are running live in the environment, yes, we can scan these as well. We scan those for vulnerabilities, and we also scan those for compliance. You'll notice this particular container is getting checked for a couple of custom compliance checks there. And as I go through there's a Docker container, Docker CIS benchmarks, custom benchmarks, anything that you can put into a script, Python, anything that you can run on a container, you can turn into a custom compliance check. So we can work with STIG compliance or whatever is unique to your environment. And finally, registries. We are able to scan registries. Well, let's pick one here. Here's an example of a very lightweight container. I've got 7 vulnerabilities in that particular layer. And you can see here the Docker file command that was used to create that layer. So we can break that down into exactly which layers have the vulnerabilities. We also scan modules so that if you want to do big patching for, say, OpenSSL, we will calculate all the vulnerabilities that are fixable for those different layers like that. Everything's exportable. I'll quickly cover the compliance profile. So you can see here, these are all of the CIS benchmarks for Docker, and then down here for Kubernetes. And you'll notice right up against here, the PCI, NIST, HIPAA, that's the reporting that we can do against those CIS benchmarks. So we can do reporting for PCI, NIST, et cetera. And those will show up here in our Compliance Explorer. So this is going to cover the entire cluster. This is going to show all the compliance violations. And here in the advanced filter, if I wanted to filter down to, say, NIST or PCI, I can apply that filter, and then I can do a report on that filter. It takes just a second for that to create. And there's my compliance report. It includes all the containers that are impacted, remediation, everything that you would want in that report. You can save this off and then show your regulator that, yes, we've been watching all of our compliance. The Vulnerability Explorer that's right above here is same story, second verse. All of the vulnerabilities in this environment. We will show the impacted version, the fixed version. We have links out to all of the different CVEs, so you can go straight to the source of the CVE to learn more about that. And the filter that I like to show off here is, if I were a developer and I'm using NeuVector, I would probably filter on the highs with a fix, because this is going to show me all of the CVEs that I can patch, right? Every one of these has a fixed version over here. And of course, we're still showing all of the images that are in that are impacted by this particular vulnerability. You also notice that these containers, so those are the containers that are running live, and those are in green because they are protected. Even though we haven't patched this CVE, I'm protecting these containers because I am using our runtime protection, which is based on the behavior of my applications, which means I can block anything that isn't my behavior. So all of these sources, which what really CVEs are, these are the sources. These would allow somebody to do something in your environment. Again, the filter here, the highs with a fix. So that's kind of for the developers. The highs without a fix. When I apply this, this is the one that the security folks, operations is most interested in, because none of these have a fixed version. And if I sort based on the CVE year up here, 2021s, 2020, lots of those, 2019. So none of these have a fix. None of these have a patch. Some of these may be a library update, like moving from Python 2 to Python 3 or something like that. But many CVEs, especially when they're first published, do not have a requisite remediation for that CVE. What are you going to do about those? That's where we need to talk about the runtime. Get through these slides. Runtime. This is what makes NeuVector special. This is what makes NeuVector unique in all the security products, right? Everybody's got scanning. Inside of Kubernetes, you are not able to see network traffic. Other products will talk about that they report network processes. Yeah, most products are using technology called eBPF, Berkeley Packet Filtering, where they are able to filter out all of the syscalls that are happening on the kernel of the worker nodes, on the hosts, right? They look at everything happening on the kernel, but then they have to filter out everything happening on the kernel because you have probably multiple VMs, you have containers, you also have operating systems, you have multiple layers of things that are happening at the kernel. So you got to filter out all of that stuff to get to what's happening on a particular container. Also, layer 3, layer 4 is all the information you're able to get from the kernel because that's the only thing that's happening network-wise at the kernel. It's a bunch of send and receive commands that contain layer 3, layer 4 information, but not the network traffic. You do not see network traffic at the kernel of the host. This is the problem that NeuVector was built to solve. Now, you may have great visibility on your ingresses and egresses, perimeter security, firewalls, traditional security, things like that. But you need to be able to see what's happening inside your clusters, because if you have any containers or have applications, services exposed to the open internet, that's a direct path directly into your cluster. You need to know what's happening here in case something is happening that you don't want to happen. That is what NeuVector does. We are able to see and inspect and validate all of the traffic that's happening inside of your cluster. We're able to identify the layer 7 protocol and validate that protocol, which means that we can see tunneling attacks at the network layer before it makes a connection to the container. That's the best place to start stopping an attack, is at the network layer. If you're waiting until something hits the kernel to report on it, that means it's already made a connection, it's already run a process. Those things have already happened that you probably should have or would have liked to have stopped before it got reported by the kernel. So eBPF, great technology for tracing and performance improvements and things like that. Kernel shims, not so popular in production environments. We also learn all of the processes that are happening inside of the cluster. So we're learning the network traffic from the network. That is our source of truth. We inspect the network traffic. We're not pinging Kubernetes for settings. We're not asking Kubernetes to tell us what network connections were allowed or network security policies or any of this. No, we're using the network as our source of truth. We're also collecting all of the processes directly from the containers. So that is our source of truth for the processes. That means we can automatically build a behavior profile and segment based on that behavior. Behavior-based, zero trust, segmentation, right? So now we can identify any anomalous behavior. We can also block that behavior. That capability is unique. We're the only product that uses the behavior of the application, can create zero trust automatically from that behavior, and allow you to use that zero trust to alert and block. That also means we can do security as code. We can export that behavior as security policies and apply that policies to multiple environments. So we can then mimic or clone that zero trust segmentation at a namespace level, at a container level, whatever the case may be, that we can mimic that across multiple clusters. That means, yes, 0-day countermeasures. We can block those. Unknown, unpatched CVEs, we block those. We can do live packet capture. So as far as kind of a forensics, yes, you can do packet capture live inside of Kubernetes. I believe that we are the only product that gives you that capability of doing live packet capture inside of Kubernetes. Also means we can do data loss prevention. We can inspect the payload of that network traffic, identify credit cards, social security numbers, any proprietary data that you want to identify and prevent from leaving on the egress. We can do that. Our data loss prevention allows us to do that, inspecting that network traffic on the egress. We're even adding OWASP WAF capabilities on the ingress. We actually already checked the ingress, but now you can, we're going to separate the like OWASP top 10 versus DLP sensors. So that is coming. I see no questions in the chat. So I'm assuming everybody's either surfing Twitter or moving okay. So we'll just assume. Two more things. I'm going to talk about the architecture. I'm going to explain our operational modes of how we discover the behavior, monitor, and protect. And then by then I'll do a quick walkthrough in the product itself, and that'll probably wrap it up for our 101. So the architecture we deploy as containers. We deploy 4 different kinds of containers. We do not use sidecars. We do not use agents. Agents are bad because they're all usually communicating directly to the Kubernetes API. That does not scale well. Sidecars do not scale well. You have to have a sidecar for every single container, every single pod. First of the 4 containers is the controller. So the controller is going to manage our policies. This is the control center for NeuVector. All of our policies. This also makes all of our API calls if we're communicating with Kubernetes. Only these containers are making those API calls. And all of our other containers are making API calls of our controller. So we're able to control the network communication between us and the the Kubernetes platform, which also helps with performance, right? You're not going to have thousands of sidecars or agents trying to talk to Kubernetes all at once. Our scanner is proprietary built. It's very fast. The CVE database is built into the container itself, so it can run remotely. It can run on a laptop or anywhere you want. It also scales horizontally. So not only fast in the scanning aspect, but also because we can scale it horizontally and automatically load balance, we can tackle extremely large repositories with hundreds of thousands of images that you're trying to scan on a regular basis. So very fast scanner, and scales well. The web UI, so everything that I'm showing you here in this web UI is making API calls of the controller. So everything in NeuVector is automatable via the API. So every single call, all the data that you see in the UI, you can pull all of this via our API. We also have a command line interface tool built into that container. So we can do command line interface if you're more comfortable on the CLI. And finally, the enforcer, this is the one that has the patents around it. We currently have 7 patents. We still have 3 that we've applied for that we're waiting for those to be issued. So currently 7 out of 10 patents issued. The enforcer sits next to the virtual switch on the worker node. And that is how we're able to inspect that network traffic. The enforcer deploys as a daemon set. That is optional, but as a daemon set, that means we get deployed with every additional node as you scale up and scale down. And that enforcer is where that plays a role in that traffic. That is the most efficient place to block or to inspect network traffic. When our founders created NeuVector and were developing it, and they were trying eBPF and different technologies, when they came across this approach, this was the one that scaled the best. It was the best performance. And that's why they patented it, because that's why they knew that was the one worth patenting. So that enforcer is going to inspect that traffic, and that's where we're going to do the enforcement. So the last thing I'm going to cover in PowerPoint, unless there are questions, is how this automated behavioral zero trust works. Buzzword, buzzword, buzzword. Now, if you got your bingo cards, I think you may have scored a bingo there. When you deploy NeuVector and you apply the license, we are automatically in Discover mode. And Discover mode means that we are going to learn all of the network traffic that is happening everywhere inside of that cluster, every egress and ingress, pod to pod, all of the network traffic. We are going to see that, and we're going to learn that traffic in Discover mode. We also learn the processes when we're in this mode. So this is where we're learning the behavior. Then when you're ready, and this could be 5 minutes, 5 hours, a day or two, then you can switch to monitor mode. And just by switching to monitor mode, you have established zero trust segmentation. Because now, anytime we see any anomalous activity at a network or a process level, we're going to alert you. We will not block it. So it's completely safe. Some customers use this as a test mode. Other customers actually use monitor mode as their established run in production mode. They just want to be alerted to things that are going on. They may not use protect mode except as a, kind of in a break glass in case of emergency, or they can have a mix of monitor and protect mode. And that's the 3 modes. We have the monitor or the discover, the monitor mode, which we don't block. And then we have the protect mode, which, as you might expect, means that we will not only alert you to any anomalous behavior, but we will also block it before it can occur. And we can block at a network level and at a process level. We can also detect common threats, 23 network-based attacks that we can detect, like DDoS, ICMP attacks, ping floods, struts, remote code execution, RCEs, various network-based attacks. We can see those in the network traffic. We can block them based on that signature. Even if we don't block it because we haven't seen it before, say it's a brand new kind of attack, 0-day, it still has to have a network connection. It still has to run processes to execute. We will see those. We will block those. We may not know why, but we know that they aren't what your normal behavior is. So that's how that automated zero trust works. So when I go to here in my network activity screen, I see a question. Oh, love that. What is the impact on a production environment? Great question. So going back, I'll just go back to here. When we are in discover or monitor mode, there is zero impact on production. And I'll repeat that, there is zero impact on production. Why? Because when we're in discover or monitor mode, we are a tap. We are not in line with the network traffic. That means we can inspect the traffic, we can validate the traffic, we can learn the traffic, we can do all these things, and we don't impact performance in production. We have also tested, and actually I shouldn't say we, one of the 4 hyperscale cloud providers recently did performance testing, very arduous performance testing of NeuVector and a variety of other products. And they scaled those clusters to 500 nodes, to 750 nodes, to 1,000 nodes. 1,000 nodes in a single cluster. NeuVector was the only product that was able to scale to 1,000 nodes, which also tells you a little bit about the performance aspects. If you can't scale to 1,000, then you're going to start seeing performance issues at a lower level. When we're in protect mode, we are, and I'm going to go back to this screen here. When we are in protect mode, these enforcers are then in line with that traffic, and we incur on average about 3% latency on that node. What you have to remember is the latency on that node is very, very small. It's very, very sub-millisecond ping times inside the node. Even node to node traffic is still usually within the same cloud environment. We're usually not scaling clusters across clouds. We have clusters between clouds. And so even in a single cluster, our latency, that 3 to 5% of a very low latency ping time is extremely small. That is why we're able to scale to those large environments like that. So I hope that answered your question. Thanks, Paul. So this network activity screen here that you're seeing, albeit a small environment, the blue lines are learned traffic when we were in discover mode. Orange lines are traffic that we have seen that we have not seen when we were in discover mode, anomalous traffic that might be want to research. And then red lines, such as this one right here, if I break this up and take a look at which one here, and you can see the X there, that's traffic that we have blocked intentionally. In fact, I have this container in quarantine at this moment. It runs this website, which if I've got it in quarantine is not going to work. So I'll just quickly take that out of quarantine. But yes, so this is where we're able to see, you can do the discover, the monitor mode, quarantine. I can do live packet capture. I can view active sessions that are occurring on that container, et cetera, et cetera. So that is kind of how we're able to do that. And here I'm going to show you real quickly what the runtime looks like. So let's just go to a particular namespace here. I'll take a look at this exploit. Let's see if we got some processes. So we've learned processes that are running on this particular container. We have seen these network connections. You can see the application protocol for MySQL, Redis, SSL, etc. So that is us inspecting that network traffic. Also file access, we automatically are protecting like etc password, user local bin, etc host, all of the sensitive system locations within the container. We automatically are watching those. You don't have to configure or do anything. You can add mount points or proprietary directories that you're creating as part of your application. You can add those and block or monitor access to those. We can even learn if the application is accessing those. And then we can export these rules. So for this one container, or I'll just go ahead and do several here, we can export. So that's my zero trust. I'm in monitor mode here. If I want to export in, say, protect mode or any combination thereof, just give it a name I can remember. And this is the export of that learned behavior. So I don't have to create this from hand. If you're creating network security policies, that's great. You don't have to anymore, but if you want to, that's fine, because we are enforcing these rules ourselves. Again, we are not a skin on Kubernetes. We don't use Kubernetes as a source of truth for our security. Well, it's one, but not for the network or processes, things like that. We don't set security settings in Kubernetes, right? We are enforcing our own rules. We're enforcing security. We're learning, et cetera. And we're doing that outside of Kubernetes as we're inside of Kubernetes. So these rules you could apply to multiple clusters. You could apply these, put these in version control, make this security as code, apply it to staging and apply it to production, and replicate your zero trust. Even early in the development lifecycle, as your services are changing and behaviors are changing, your developers can just export this automatically as part of their pipeline build. They don't even have to lay a finger on the keyboard to add extra steps. Export it automatically, put it in version control, test it in monitor mode in QA, then establish it in your staging, prod, et cetera environments. Thank you for attending. We appreciate you very, very much. And if you have any more interest in NeuVector, reach out. We're happy to talk to you. And have a great day. Thank you, everyone.